Okay, welcome to Unit 2, Quadratic Equations. This is day 3, completing the square. First off, before you get into this, you're really going to need to know what the forms of perfect square trinomials are. And that's like a squared plus 2ab plus b squared can be written as a plus b squared. And today we're going to focus specifically going from this form on the right to this form on the left. You can also see a squared minus 2ab plus b squared. That would be when you have a minus b squared. And we're going to see both of these today interchangeably. On this first problem, we're to find the value of c that makes x squared plus 12x plus c a perfect square. So we're looking to make it in the form a squared plus 2ab plus b squared. When I look at that, I'm trying to figure out what the b squared would be. If this is equal to 2ab, I already know the value of a is x. So 2 times x times b. Well, b must be 6. I know that by just taking the 12x and dividing it by 2. So that's actually what we're going to have here. So x squared plus 12x plus... Now, remember, 6 is going to be squared for this term out on the end here. So it's actually going to be plus 36. There is a formula that we'll be using, which is b over 2 squared. If you take your b value, in this case 12, and divide it by 2, and then square it, 12 divided by 2 is 6. 6 squared, 36. So c equals 36 is my answer. But it did say write the trinomial as a perfect square. If I were to write this as a perfect square, it'd be x plus 6 squared. Because this is a perfect sum, alright? It's a plus b squared. And we're done with this problem. Alright, what this box is saying is you can use the process we just used on the previous problem to actually solve equations. And you can see where you've actually got the formula I just showed you, that the c term is going to come from doing b over 2 squared. And that's what we're going to use when the leading coefficient is 1. We'll see what to do when the leading coefficient of the equation is not 1 in a little while. I'll take you through the process right now. Alright, on this problem, number 2, we're going to kick the constant term to the other side first. Alright, because right now this is not a perfect square trinomial. If it was, go ahead and get going. By the way, in this problem, honestly, I would just do it by factoring. X plus 6, x minus 2, and it's factored and go from there. However, I'm going to do it by completing the square because sometimes you cannot factor it, and that's where completing the square is going to be handy. Alright, so here's your process. Take the constant, get it to the other side. So that's going to look like x squared plus 4x, add the 12 over, equals 12. Now we're going to actually complete the square right here. This is going to be coming from b over 2 squared. So the value of b is 4, and I'll put that in. 4 divided by 2 is 2. 2 squared is 2, or excuse me, 4. So now that's what I'm going to use right here to complete my square. I'm going to use a plus 4. However, remember this is an equation, so if I add 4 to one side, I must add 4 to the other. What that does on the left-hand side of the equation, this is now a perfect square trinomial. It's in the form a squared plus 2ab plus b squared. A is x, b is 2. So it's x plus 2 squared. Equals, on the right-hand side, I have a 16. The reason why that's really handy is now I can undo the square in the process of solving for x. So if I undo that square, it will be by taking the square root, the positive or negative square root of 16, which is positive or negative 4. Because it came out very pleasant like that, I'm going to go ahead and split it up into two equations. So x plus 2 is either equal to negative 4, or x plus 2 is equal to positive 4. And now I'm going to subtract 2 on both of those equations, and I get negative 6. Or, over here when I subtract 2, I get 2. And there's my two answers. Now, again, looking back, I would have used graphing calculator, I would have used factoring on this problem, but that's because these answers ended up being rational. On the problems that you can't factor, you're going to be able to use completing the square, and we'll see those coming up. Another problem, this one is not factorable. There's no two numbers that will multiply to 11 and add to 4, and your calculator is absolutely no use to you here. You really have to use completing the square here. You get imaginary roots on this problem. First step, go ahead and kick that 11 to the other side by subtracting it. Now I'm going to complete the square by doing b over 2 squared. The value of b was 4. 4 divided by 2 is 2. 2 squared is 4. That's what I'm going to add to both sides. Plus 4, plus 4. And what I'm going to get now on the left is x plus 2 squared, because 2 plus 2 is 4. 2 times 2 is 4. Equals negative 11 plus 4 comes out to negative 7. Now I'm going to plus or minus the root here. X plus 2 equals the positive or negative root of negative 7. This is where the imaginary root is coming from, that you're taking the root of a negative. So I'm going to go ahead and pull that out as plus or minus I root 7. Remember, I represents the root of negative 1. So it comes out right there. I'm going to subtract this 2 over to the right hand side. So x equals negative 2 plus or minus I root 7, and we're done. For the last problem that we're looking at, same situation. You can't factor this. This is actually going to be complex roots as well. So we're going to start by subtracting the 5 on both sides, and that's going to result in x squared plus 1x equals negative 5. Now I'm going to complete that square by taking the value of b, which is 1, and I'll do b over 2 squared. So 1 over 2 squared. 1 over 2 can't simplify. 1/2 squared is 1/4. 1 squared is 1. 2 squared is 4. I'll add that to both sides. Plus 1/4, plus 1/4. On the left side, this will factor to x plus 1/2 squared. Remember how it's always that b over 2 value. And that's also because 1/2 plus 1/2 would be 1, and 1/2 times 1/2 would be 1/4. And that equals negative 5 plus 1/4. Really quick, I'll make that negative 20 over 4 plus 1/4. So I know it's going to be negative 19 over 4. Now I'm going to plus or minus the root on both sides. So x plus 1/2 is equal to the positive or negative root of negative 19 over 4. I think you see where this is going. Hopefully, is that we're going to have an imaginary root. So this is going to be plus or minus root of negative 19 over 2. Now that part was easy. I took the root of the denominator. I could not take the root of the numerator. And 2, when you see an imaginary root happening, always put that on the numerator. It will be an easier representation of it. The negative will now come out as an I, the root of negative 1. So x plus 1/2 equals positive or negative I root 19 over 2. Root 19 can't simplify. You would want to simplify it any that you could. Like if it was the root of 18, you'd simplify that down to 3 root 2, okay? Can't do that here, so now all I've got to do is subtract 1/2 over. So x equals negative 1/2 plus or minus I root 19 over 2. And again, I'd like to actually represent that as one fraction. So for my final answer, I have negative 1 plus or minus I root 19 over 2. Because they were both had a denominator of 2, and I was able to combine them as such. And now I'm done with my problem. So that's completing the square in a nutshell. I know that you're probably going to have questions if you are absent or if you are relying on this video as your initial instruction. Definitely let me know what questions you've got in class.